from CNC at home, and I found a router project on the side of the road. Boop, boop.
What's that? Well, it's either a 9 or a 6. Looks like it's fallen off my neighbor's mailbox. I've had the same problem with mine, and what I did was I used this nice red reflective tape in the CNC router and cut out some numbers. Let's go do that for my neighbor. To generate the G code, I'm going to use a program called F-Engrave. It's just a simple free program that lets me set certain parameters, such as the height of my cut, the width of the text, some spacing, that sort of stuff. And I can set my cutting parameters. Here I have 400 millimeters per minute feed rate and a safe zone of 2 millimeters. I can select the font. For this one, I'm using a Windows font called Stencil. And for the text, I just key in down here on the input box what I want, so 9465. The next step is to go under Settings and set up my V-bit parameters. So I want to make sure that I'm using a V-bit. It's a 20-degree V-bit, and it's a 1/8 inch or 3.175 diameter. And I'm going to use a negative 0.4 millimeter cut depth. So that basically goes from 0 down into the material 0.4 millimeters. I went ahead and did a calculate on that, and we'll save the G code out to a file. Now I need to manipulate this. If you remember, our spindle motor can't start at full power, so I have this ramp up code. I'm just going to copy it from my ramp up template and paste it in here where the M3 is, which is the start spindle command. So I'll replace the M3 S800 with my ramp up code. We'll just paste that in. Give this a save, and we're ready to bring that into the sender. Here we have our G-code sender program, and I'm going to go ahead and open the connection to COM18, which is what I have set up for my router. And we get an error alarm because I have it set up to require a homing when it gets turned on. So I'll click on the homing button, and we'll go take a look at the machine as it first homes the Z-axis. So it brings the gantry up until it hits the limit switch, backs off, and it'll come up slower, get the perfect position. Then it does the X and Y position. Here you can see the X limit switch as the gantry comes over and touches it. It'll back off and then push in slowly until it hits the limit again. Now we want to zero this with our material. I did make a mistake here. Since I put an extra wasteboard on top of my wasteboard, I zeroed to the wasteboard. I got that corrected later. I should have zeroed to the top of my material once I put that in place. I'll just bring the tool down, and then I run a macro that comes down slowly until it touches, and that makes a connection, tells the controller you've connected, does some math, sets the 0 to the top of the working surface. With our material in place, I want to do a test cut, so I raised my Z up a couple millimeters so that it won't actually cut the material. And I want to make sure that my minimum and my maximum Y don't exceed my material. And it looks like the positioning is really good on this. So once this, I'll just go ahead and stop this test and start the real cutting. After readjusting the Z to its actual position, I started the cut. Everything started out well, and then all of a sudden, the tool caught and the tape gave loose. I wasn't paying close enough attention. I didn't stop it right away. It wouldn't have helped, but that's nice to be able to just stop it right away. So I cut a new piece of material and put more masking tape on to hold this down. Hopefully this will work. So we restarted the cut. Got past the first failure point, so things were looking up. But then I saw the tape start to move, and I went in. I was going to grab it with my hand and hold it in place, but I was too late. The whole thing moved before I could do that. We have another wasted piece. The next solution, use the good masking tape to hold your project down. I was using the kind of cheap stuff. It didn't have as good a gripping power. So I got the green tape out and used that. And it worked really well. It held it down nice and solid. During the cut in our sender program, there's a visualization option that shows me where that yellow bar, where the spindle is cutting. And then you can see the white line disappearing, giving way to gray. That's always ahead of the cut, and that's the code that has been sent to the controller. So it always buffers up a little bit of code ahead of time. So that's always kind of neat to see. That was a successful cut. Everything cut nicely. We'll go ahead and take that out of the machine, and I want to do a couple more so that my neighbor has some options he can do with this. It's kind of foggy out, so hopefully we can see this. But he got the numbers put up on the mailbox. I made him 3 sets, so there's one on the front, on the sides. Hopefully those stay on well for him. Remember to give this video a thumbs up if you liked it, and subscribe to the channel. And enjoy doing your CNC at home projects. Oops.
Hi, AT from CNC at home, and I found a router project on the side of the road. How's that? Did I say it right? Hi, AT from CNC at home, and I found a router project on the side of the road. This is AT from CNC at home. I found a router project on the side of the road. Hi, AT from CNC at home. I found a router project on the side of the road. Hi, this is AT at home. I found a router project on the side of the road. Hi, AT from CNC at home. I found a router project on the side of the road. Hi, AT from CNC at home, and I found a router project on the side of the road. Hi, this is AT from CNC at home, and I found a router project on the side of the road. Hi, this is AT from CNC at home. I found a router project on the side of the road. Say it right? I did it.
Hi, AT from CNC at home. I found a router project on the side of the road.